So I made this wheel in FreeCAD, and I had to think in a way that I haven't quite thought before when making this, and I want to share some of that with you. Now, let's take a look at the dilemma that I was grappling with. So first, I'm going to open up a new part. And from my new part, I'll make a sketch, and I'll make a rectangle, and we're going to just extrude that using part design really quick. Okay, now that I have an extruded part, let's say that I need to make a body using the older part workbench. Well, part is useful still because curves and curve shapes and surface and all of these things are still kind of built to interface with part. And if I make something outside of part design, I can't really make it part of part design. Let me show you how. I'll jump into my sketcher. I'll make another sketch here on this face. I'll make a circle this time. And then I'll use part to extrude it. So now that I've extruded this, you can see that I have this body, and everything that's a part of this body is part design. When I collapse it, my extrude is outside of my body. So they're actually two separate bodies. In fact, I can go to my extrude, and I can tell it to be symmetric so that it goes both directions. And they're just overlapping, right? We don't actually have an edge or anything. They're not merged. So this is a problem if I want to implement this cylinder into my part design. So I can go to part design here, go into my body, and from part design, I can try to do a Boolean and Boolean in this pad, right? But it doesn't want to go. And so I'll get rid of my Boolean, and maybe I can just drag and drop this into a body. And so now I have an edge, and I can make a fillet. And sure enough, I can fillet these things. So that looks like I actually took my extrude, which now has a broken sketch, it looks like. Yep. And I was able to put it into my body. But what if I want to change the diameter of this cylinder later on? Right? I can't really see an option to change diameters. So I can use base features, and they're especially useful when you don't have a part that has a history like a step file, and you're trying to import it into a part design body and get a history out of it. All that's very useful. But in this case, if I want to import this cylinder into my body, I really sacrifice the ability to update it. So if I edit my sketch and I make it really big and I rebuild my part design, then we get dependency cycle errors and just all kinds of things. So it's not parametric if we do it this way. This is how I am solving the problem, to be able to take things outside of part design, bring them into part design, and make sure that we can make our adjustments that we want later. I just finished editing the main part of the video, so I'm going to do my final editing and put it out. Here's the video, and please enjoy. Now, in FreeCAD, I have made the most advanced wheel that I've ever made, and this combines functions from the surface workbench, the curves workbench, the draft workbench, the part workbench, and it is all contained within a part design workflow all the way through. So this was a case study not only in making a wheel that I think is pretty cool, but also how to implement a workflow that you can do that with. Now, I'm going to put out an abbreviated video, so if you're just interested in the workflow, check out my shorter video on that so you don't sit through the modeling of the whole thing. But this is also just how to make the wheel. This video is how to make the wheel from scratch. So let's go through making this, which I love the style of it. It's my personal style. And we'll see where we go. So I'm going to start a new part and we'll get started. So this is FreeCAD with a new part, completely from scratch. This is the part design workbench. And yeah, let's get started. The only thing I changed in the UI is I went to dark mode and I set my units to inches. Let's create a sketch on the XY plane, or however you want to orient your wheel. we're going to be working on the center hub for now. I'll flip my geometry to construction. We'll add a vertical line. In fact, I'll go with a polyline, which is much easier. I'll add a horizontal, another vertical, and I can give this some preliminary dimensions. I'm going to hit D on my keyboard for dimension, and we'll go with 0.5. FreeCAD has updated their hotkeys to be the way that I like, and I have to give them thanks because I spent so much time in other videos whining about it that I'd better say thank you to the developers for doing something awesome and bringing the awesome hotkeys back. So we're going to give some dimensions here of 0.7, 3.1. We'll give this vertical 2.25. And you can tell by the green ends of our lines that we are fully defined. And I'll make some driving geometry. So again, just hitting that button and flipping back to white. I'm going to make an arc that starts and ends at these endpoints right here, right? Now I'm going to hit C for coincident on my keyboard. And we're going to take this arc center and make it coincident along this line. And you can see that our arc turns green. It's fully defined. We'll close that now. So all we have is just an arc floating in space. And now I can go to my origin and hit the space bar. And the space bar, of course, toggles things visible or not visible. And I'll grab this vertical axis, right, that runs right by my arc. And standing on that axis, I'll click on the datum plane. And I want the datum plane to be 36 degrees off of the plane that I sketched my arc on. So I always have to give these a few dimensions here. I want to rotate it, so I better go to these rotate instead of the direction axes. And yep, that's the direction I want to rotate it. So I want to say 90 degrees because 90 degrees will make it parallel with the sketch, right? And then I'm going to say plus 36 because I want to be 36 degrees more than that. And we'll say okay, right? So we're going to make a 5-spoke wheel, and 360 divided by 5 is going to be 72. 72 divided by 2 is 36. So we're saying we're going half of the spoke around. That's how I got that 36. So we're going to make, as far as one spoke is concerned, half of our hub, and we can mirror that later. So I've created my 36 degree datum plane, and I'd like to make my next sketch. So we'll go ahead and select this datum plane. We'll sketch on that. Let me see, we're looking vertically now. So I'll make an arc, and I'll make, once again, this little structure of construction lines that help me define things. I'll hit C and make sure that these points are coincident, horizontal. We're going to do D for dimension, right? H for horizontal, D for dimension. We're going to say 0.5 here, 0.75 here. From the origin, we're going to give this a distance of 0.7. And then from here, we're going to give this a distance of 3.1. Now I have my arc center right there, right? That's my arc center point. We want this to be coincident on this horizontal line, so we're going to say C for coincident and click on the line, click on the arc center. There we go. I can hide with the space bar that extra datum plane. Now we'll choose this plane as a reference, and I'll click on my datum plane button once again, and we're going to, in the Z direction, say 0.5. And that went in the wrong side, so we're going to flip sides there. And there is our datum plane. Now, if we've modeled this correctly so far, the endpoint of this arc is going to be sitting on this plane, and the endpoint of this arc right there is going to be sitting on this plane. And sure enough, we're both sitting right in that plane like we want. So we're going to create a sketch on this plane, again, clicking the sketch button. Now I can create this create external geometry button, and I'm going to import my two arcs. And then I'm going to create an arc. There's my origin, right? So I put my arc center right on my origin and go from one point there to the next point. Now we're not coincident, are we? So I'll say C for coincident and click on both of those points, and then we'll snap in the right spot. Okay, excellent. So I'm starting to create the wireframe for our hub. Now let's talk about why I've made it that way. If I open up my other part here, my other wheel, and if I go right into my hub here, I want to make a shape that looks a lot like this. Now it is very hard to make this particular shape in part design. I think it can be done, but it became so much work that I kind of gave up on doing it, right? We want this to be relatively horizontal to tangent. You can tell that's not quite for a specific reason, but that's very close. And then again, horizontal to tangent down here. That all kind of blend into this very minor rise over here. So this shape is quite difficult, a lot more difficult than it looks for part design to do. So we're going to be using some external features, and our wireframe is going to create that. So we need to create something that tells what this outer edge has to be shaped like, right? It looks like a loft that is normal to profile on each side. We really don't have that in part design. We really don't have that in part. So how do we do normal to profile lofts? We're going to be using some features from the curves workbench to assist us. So let's jump back. All right, so we're back here. And how do we get that? Well, the first thing, I'm going to create a view. An easy way to do that, right? So we've got our datum plane here. We have our datum plane here that is at that 36-degree angle. We're going to create a sketch on that plane. Now we'll notice how we're oriented, right? I actually want to be looking at this from the other way. So if I reset my sketch view and I click on my view cube, 1, 2, 3, 4 times, we've flipped our view. Now I'm going to go into my view, and we want to have this line, right, kind of between us and the line and the plane that we're sketching on, right? That's the orientation that we want. So once again, flip 1, 2, 3, 4. We flipped our view 180 degrees. We're going to say view, standard views, and then store working view right here. Okay, now that we have that view stored, we're going to head over to the curves workbench. And we're going to create a certain B-spline that allows us to be tangent to horizontal, do our curve, and then tangent to the plane of this sketch as well, right? Producing the edge shape that we want. So I'm going to hover my mouse over here and see our freehand B-spline. And I'm going to select that. Now there are so many different options and functionalities for this specific freehand B-spline. I would need to make a long video just for that. So first off, I'm actually going to delete that, because what I want to do is stand on this edge, stand on this edge. And so once I have both of these endpoints selected, we'll grab our freehand B-spline, and we have, of course, a spline that is going straight. Now, right now, I want to be normal to this plane, so I'm just going to click on the view cube to make myself normal to this plane. And actually, you know what? I want to flip my view around and be normal this way. So click my view cube, make sure that I'm totally normal to this long arc sketch that I made. I'm going to select the edge of this freehand B-spline. I'm just going to hit T on my keyboard. Now, it doesn't look like I did much, but it makes it normal to my view when I hit T, or I guess tangent to the normal of my view. So as long as I'm looking normally of where I want that B-spline to be tangent to, and I hit the T key, it changes my B-spline. Now it always moves toward me, so I want to be very careful about, how my view is. If I were to look at it this way, it would be tangent to me coming out of the screen towards me. Next, I'll go into my view and I'll go to standard views and then recall the working view that I stored earlier. Now I can highlight the endpoint of my curve, right, which is going to be right there, my B-spline. I'm going to hit T. You can see how that changed as I hit the T key. And I'm not quite tangent both ways, am I? So let me make sure. I'm going to go View again, Standard Views, and Recall Working View. So we're going to highlight that spline again, T, and there it goes. So I don't know why I had to do it twice, but look at that beautiful curve, right? That's exactly what we want. Normal and normal. All right, now that we've made the correct curve, let's use some of these tools, which again are not in part design, to make this. We're going to go to our part workbench, and we're just going to create a surface here. We want a ruled surface, which is this button right here, create ruled surface. And you know what? I'm still editing my freehand B-spline. Now you're going to notice something. I'm going to double click to stop editing my B-spline, and it goes straight. And we say, oh, do I have to do that view thing all over again? So if I double click, which puts my spline in edit mode so I can change things, it's curved again. And we think, what's this behavior? Why is it not the shape that I want? And the reason is the spline needs one more point. So if I go back to the curves workbench for a sec and I hover over this, I can see that I says insert point in selected segments. So I'm going to click this little straight line here, and I'm going to hit the I key, and it's going to create a point. Right, and that doesn't seem to change the geometry of our spline at all, but it does create the point that I need so that when I double click off of my spline, then it has the shape that I want. So now I can insert my ruled surface with a good peace of mind. I'm going to select my sketch, so I can say sketch 001, hold control, select sketch, right? So I have these two parts of my sketch highlighted. We'll go to part and click on this ruled surface button. Now we're ready to create a point cloud that will create the surface profile that we want. I'm going to click on my ruled surface. I can do so from the tree, and I can click on my sketch 002, which is that front little sketch you can see in green there. And then I'm going to hold control and select my freehand B-spline. So I've got my ruled surface, the front and the back or front, or however you want to say it, selected. We're going to go to the curves workbench, and I'm going to click on sweep on two paths, or I guess two rails, depending on how you want to say it. When I click on this, having this sketch and this front sketch and the surface selected, it'll create a point cloud for me, right? You can see all these really beautiful kind of rainbowy points floating in space. And this is an approximation of the surface that we want. And so I can then stand on my sweep on two rails in the history tree. And we're going to say, I think it's right here, approximate. So approximate points to NURBS, curve, or surface. Click on that. It'll take a second to compute, but we've got now a beautiful surface generated from those points. And that happens to be the surface that I want. Now we'll notice that if I go into, say, my original sketch, I made this 3.1 inches and 0.7 inches, right? These are just to give it a little bit of extra meat. My actual solid is going to be 3 inches and 0.75, so we're going to be a little bit within the surface, and that's so that we don't end up with a problem of something coming outside of the surface that we want. But now that I have a nice reference surface, I can create this XZ plane. I can create a little extrusion. So I'll jump into creating a sketch there. Again, I can use part design, right? I'm using a hybrid of part design and part features, which there's no problem doing for now, at least. And we'll create a sketch here, a sketch there. We'll make sure that I'm H for horizontal. and I've got my origin point, and this line will now be horizontal. I'm going to say D for dimension and establish a 36-degree difference there. I'm going to make an arc, right? We'll start from our origin there, and then from there to there. I can make a radius of 0.75. Again, lying comfortably within that surface. And then where does this line end up? Well, I want this line coincident with the origin, so I'll select this line, hit C for coincident, and select my origin. Again, I don't know if that went, so there you go, hit the C on the keyboard, there's your line, there's the origin, and there it snapped, right? So we're running right on the edge of that surface. We'll make one final arc. Again, starting from the origin, we'll go to the other end of the line and the other end of this line, just like that. Now, I don't think those merged, so I'll grab coincident with C key and add that. Now, what radius do we want that line? I think that's our last degree of freedom. We're going to say 3 inches. Okay. With that being done, we're going to close. And now I want to extrude this with a part design workflow, right? So it's going to be very confusing to have all this stuff that is not part of part design, right? Because this approximation of curve breaks down into all this stuff that ultimately belongs to the curves workbench, and we don't have the tools up here to bring this into part design, right? So what I'm going to do to implement these features is create a folder or a group right here. And I could say, with this group, I'll give it a name. Formation of hub surface is what I'll call it. And I'll take everything that belongs with that, which is everything but sketch 4 really, right? All this stuff was concerned with creating that surface. And I'm going to drag and drop it into this group. And I'm going to take my approximation curve, and that also belongs into everything that I used to formulate the hub surface that really wasn't part of part design. And now I've got this sketch that I'm going to extrude, and I'm going to use part design to do it. And we're going to say, create a shape binder, right? So this is, I've got this active body right here, right? That's my part design body. And this hub surface, right? If I want this approximation curve to be in my part design body, it doesn't work, right? You get a broken base feature. So I'm going to hit Control Z and get rid of that. So what I can do to take my approximation curve is say, highlight this approximation curve and click on Shape Binder. And I get this yellow shape binder. So if I hide my approximation curve, I've got this yellow shape binder right here. And if I go to edit something, edit sketch, I'm going to say 3.5. We're going to make that longer. You'll notice that my approximation, or my shape binder, changes with the changes that I made before. Again, I'm not going to mess with my surface too much. I'm going to say 3.1 as it was before. We'll recompute that. But now I have this reference that is inside of my part design body. And all I really need to do is take my sketch. We'll create an extrusion or a pad. And we're going to say to face. And we're going to click on our face right there. That references everything that we've done. So we're going to say OK to that. And I can hide. And so now I have this binder. And I'm going to rename this binder, right? I can just hit F2 on my keyboard. We're going to say, how about hub surface, C formation, or better, of hub surface group. So I have a active reference in my tree that tells me exactly where I can go and edit things. And that shows up in my part design body. So no matter what features I use, I can use the ideal and optimal part design workflow that just has a simple tree that goes all the way down, easy to roll back, simple to read, and I have all the stuff that isn't part of part design that can drive that without any of the cons. So this is going to be my ideal workflow for whenever I want to use part design, but all the advanced features that are outside of part design. And that is the reason why I'm making this video. Also, to make a wheel that I think is pretty darn cool. All right, now that I have that made, I want to do a few things, right? I'm going to do a mirror. And it already knew exactly how I wanted to mirror it. How awesome is that? So we're going to say okay to that. I can hide some of my sketches. Right, so there's a sketch. I can use the spacebar to select and hide it. Now we've done pretty good on getting that to be smooth. It's not perfectly smooth, so we can start adding some things that will smooth it out. Now, the general wisdom, which is very, very good, especially in FreeCAD, is to save your fillets till the end. Now, I'm going to put a hole right on that edge. So the question is it better to put a fillet right there so when I add the hole, everything is smooth and I don't add two fillets? Or is it better to save my fillets to the end regardless? Now, it's ultimately up to you to make that decision. There's pros and cons with both. I'm going to add the fillet right now. I'm going to give it a radius of 0.25. Feel free to only add fillets at the end. That is a great strategy also. It's up to you. Now that I've added that, I want to add a groove. So I'm going to go onto my XY plane, create a sketch on my XY plane, and create a hole for a lug nut. So now that we're in an active sketch, I'm going to use this little face right here, of course, view section. And that will allow me to see my sketch elements as I start sketching. So there's a little 45-degree angle for the lug nut to butt up to. Right, I'm going to hit D for dimension, click both lines, and say 135 to make sure that that's the truly correct angle. I'm going to hit H for horizontal. We'll select my origin, select this line end here, and then I'll probably do D for dimension and give this a distance of 0.5. Now I'm going to create like a little floor there and a vertical. Again, I could be using multi-line or polyline to make this even easier. And we're going to say D for dimension. And we'll give this a distance of something like 2.25 off of our center. And then we'll give this a dimension of 0.25. And then from here to here, we'll give this 0.625. So it's a pretty good size hole, right? You can get a tool over a lug nut, hopefully. I don't exactly recall the exact dimensions that it's supposed to be, but I think this is a reasonable estimate. We'll give this a distance of 3, right? So we're going to revolve this, and for that we choose groove. We'll select a reference to rotate around, and we're going to choose this guy. And that makes a pretty good size lug nut hole. Say OK to that. And just like that, now we have our groove. Again, it is really hard to know when to fillet something and when not to. If in doubt, save your fillet till the very end. I'm going to break the rule a little bit and put some fillets on while I know that I have a pretty simple model and I can pattern these fillets, right? Because I'm going to pattern this hub. And perhaps patterned fillets are going to be great for consistency. So in other words, if I don't fillet right now, after patterning, I'm going to be putting 5 fillets down instead of just these 1. So that's a consideration, right? But it's also a great strategy to save all your fillets till the end. Again, it's up to you. I'm going to choose a fillet that I'm going to pattern with using a body, and I think that might simplify things. I don't know for sure if that's the absolute best thing to do, but I think it's a pretty interesting and reasonable strategy. So we're going to add some fillets that are going to be patterned, saving our overall number of manually applied fillets, which may simplify the computation of things down the road as well. Not sure, but that's my running theory. I'm going to say 0.0625 on this radius. If we preview this, we can see that we've smoothed that out quite nicely. We're going to go back to select and preview. Select again. I'll add this and this to make our fillets pretty clear. Preview. I'm not seeing that come through. Let's try 0.06 and see how that works. There we go. Yep, so I think our fillets were just a bit too big to show up, but we have those fillets. We're going to say OK. And if we move on, I'm going to apply my polar pattern now. So for polar pattern, we're going to choose, of course, polar pattern, and transform body is what I want. We're not going around the correct axis, so instead of our base Z axis, I'm going to choose our Y. And we're going to do this to the correct number of patterns. There we are, right? So I've got this hub. Again, the fillets are quite simple. This is one fillet that's been patterned as part of a body that might simplify your fillets later on. That's why I added it. And while you're at it, you know, it might be a good idea to add some fillets down here and on these edges, right? Maybe a very slight one. I'm going to go ahead and do that, actually. So I'm going to delete this pattern, fill it, and then redo it just for the ease of it. We'll go with 0.05. You know, I start talking through something and then I think, hey, that's a great idea. So I'm just going to do it right here on the video. Select again, there, and you know, I'm going to go down there too. Preview, everything looks good. We're going to say OK. We're going to reapply that polar pattern. We're going to go around our y-axis as before and change this to 5. And we're patterned once again. Now we can do a polar pattern that's going to change the outer shape of this wheel. It's going to delete that fillet that I just made at part of it, but I think it's worth it because I've reapplied the fillet after the cut and it seems to reapply fine. So we'll choose our XY plane, create a sketch, and then make sure that I know where I'm oriented here. It looks like this side is what I want to work on. So reset my view, and I'm going to do this side where it's lowest, and this plane intersects the lowest point there. I think that's the only part of this wheel where you have that, and it is. I'm going to insert this geometry right there and there. Okay, next I'm going to choose an arc right here and another arc right there. Now, if you haven't seen my short, remind me to put a link in the description. I'm going to choose a polyline here and use the method, right? So we put our polyline down, we hit our M key 3 times, and it creates a tangent arc for us, right? Way convenient. I'll hit the T key for tangent, and just like that, we're going to do E for equal and make sure that these two arcs are the same, equal radius. T for tangent again on this arc and our imported edge, if I can click both. And same thing here, just like that. And then I can give this a radius. I'm going to say D for dimension, of course, and add 2 inches. And so now where are we not equal? Well, we want this arc to go around this hole, right? So we're going to hit our import geometry. We're going to hit the circularity of that hole. I'm going to say V for vertical and make that hole center there, right? I like doing vertical because it minimizes the number of constraints that we need to center this arc over this hole. If I do coincident, it will lock the X and the Y around our hole center, and that's one more constraint than we need. We only need vertical. So it simplifies the way that the sketch is calculated and helps prevent errors. I'll make an arc whose center point lies right here. The other thing that I can do is create a polyline, and once again, the 3M method. But that actually makes it tangent in the wrong direction, so I will use a center point arc. Ignore that method. And just like that, we're actually fully constrained. One thing to note, when I pattern this, this edge is going to be butted up against another edge. There's a possible 0 thickness there, right? Where one cut edge is butted up right against the next zero edge when we go to pattern this. So we're going to see if this works. We're going to go with pocket. They're going to say symmetric to plane through all. And that's weird that we're getting an error. We shouldn't get an error at this phase. So let me take a look here. Oh, so I have a redundant constraint. Interesting. It's telling me to remove constraint number 8. And we have 1 degree of freedom, but the sketch is fully green. Looks like this arc size. Okay. So I'm just going to make this large. We're going to say E for equal and make this equal there, right? So we're going to close that. Once again, we can choose pocket. We're going to say through all, symmetric to plane, just to make sure our intent is clear. And we have a nice kind of divot around. Now this is where we're going to watch for zero thickness geometry. This cut ends where the next cut begins in that exact same spot. I feel like Open Cascade, kernel of FreeCAD, is kind of sensitive to those kinds of situations. So we're just going to be cognizant of what's going on there, right? So we choose tool shape, which is going to be our cut right there. Add feature, click on the cut. Yep, there's our pocket. We're going to pattern this around our base Y axis. And we're going to say 5 occurrences. And it worked, right? If that hadn't have worked, what I would do is go back into my pocket sketch. So if it's not working for you for some reason, just back this off, like make this endpoint like a few thousandths of an inch over here, or make it move a few thousandths of an inch off this edge, and then redo it, and the pattern should work. So it's probably working for you, the viewer, if you're following along. If it doesn't, that's going to be the reason why. There's going to be some kind of zero thickness, non-manifold kind of thing. So just watch for that. We always want to be cognizant of that stuff, right? Next, I want to make a sketch of a spoke, and I'll have it be on this bottom face. And so we're going to start forming our spokes. Now I'm going to use, again, tools that are not readily available in part design to make this spoke. So I'm using the part design workbench tools, but then I'm going to have to go do the curves workbench or something else. And that is where that body, the spoke body, isn't going to fit in my part design body anymore. So that's when we're going to use our groups. So for right now, so I'm going to start sketching here, and I'm going to start by making an arc that is centered around the origin. And then I'll grab a polyline, and again, just use 3 M's, 3 M's, 3 M's, and then we're going to say T for tangent, V for vertical, and we'll make sure the endpoints of each arc here are vertical. I'm going to say D for dimension. We'll take that arc endpoint and make it 2 inches. We'll make this arc 0.125, and the other one will size accordingly, of course. I'll grab this arc endpoint 1.86, and then this one will go 0.85, right? So that should be a pretty good spoke profile to start off with. And I'm going to close and exit my sketch. Now I want to make profiles for this wheel to go through, and I want the sweep of this spoke, I want that sweep to be a 3D profile that is non-constant radius and just very organic, right? I think that's how you make a modern looking wheel. So I'm going to choose a plane to sketch on. I'm going to choose this flat plane here. I'm going to save this. You never know if you need to recover something. And we're going to hit the sketch button and create a spoke sketch path. For that, I'm going to create a spline here, a B-spline. We're going to have the first 2 points on that horizontal sketch axis and maybe 2 more points. Right, so it proceeds out with a nice non-constant radius And then I have the first 2 points on this axis, which means that no matter what this curvature is, this endpoint is always tangent to horizontal. I'll create D dimension, and we'll give this a distance. I'll go with 2.375. So it's just kind of in front of our sketch profile there. And then over here, I'll create a dimension. We're going to make it 10, right? So it goes a little bit past. If I plan on making an 18-inch wheel, 10 inches is probably appropriate, so it goes way past our outer diameter, but not too far past. We're going to go with a vertical dimension here. Off the origin, we're going to make that something like 4.375. And so I can't really move around this endpoint nor this endpoint, and I can just take this intermediate sketch point and this one that I can slide and make kind of a nice non-constant radius path. Let's say that I'm happy with that, right? If I want it fully constrained, I can constrain these center points right here and right here, these guide points, but control points, I should say. But I'm happy with that. We're going to say XY plane. Same thing, right? We go to edit our profile, and I want to make a B-spline on there. I'll use 4 control points. I'll go V for vertical and have this come vertically out of the wheel. We'll do the same dimension, 2.375. Same dimension over here. We're going to go out to 10. And then I can make this height and everything else kind of whatever I want. I will have this, I didn't mean to add that. I will say H and have this point and this point be horizontal, so our spoke kind of evens out, but I think that's a pretty good profile, right? I'm pretty happy with that overall. So give this a dimension here. We'll make that something like 3.75. And I think we're good, so we're going to close that. Now I want my 3D path to be a mix between these two curves, a blend, if you will. When I look at it completely from the side, I want it to look like this. Completely from the top, I want it to take this path. And so we're going to go to the Curves workbench. And from the Curves workbench, we see this mixed curve right here. So I can choose sketch 8, sketch 9, and then click on mixed curve. And it generates a curve that makes it so that if I look directly down on this from the top, I can see that it looks just like my sketch. If I look at this from here, right, we can see like the back, we can see the path that the sketch takes. So that's great. We do stand in need of a terminating sketch for our spoke. And so I'm going to choose this little point at the end of my curve, as well as the curve itself. And I'll go to the sketcher, not the spreadsheet rather, but the sketcher, and grab a sketch. Now it's asking us to do a frenette. I'm going to go with normal to edge, right? So our sketch is going to be just normal to the edge of our curve, just like that. That is something that we can work with. So I'll make a line here. And I'll do D for dimension, of course. We'll take this to, there we go, 1/2 inch. And then like this, a distance of 3.75. Take a polyline, and of course we'll do the method, hit the M key 3 times. Again over here, hit the M key 3 times. We're going to say E for equal, and make sure that these arcs are equal. We're going to make sure that these arc ends are vertical. And then I need to give this a size, so we're going to say about 0.5, right? And now I can give this an angle just by clicking again on the arc body after I give it a size, 135. 1.35 degrees, now 135. There we go. Now what is not constrained? So I'll click and drag, and it looks like we need to be symmetric. So I'm going to hit S for symmetry. We're going to go line end, the other line end. We're going to make that line symmetric right around that origin. Again, hit S, click point, point, and then your axis of symmetry, and your line will snap symmetric. We'll switch to construction geometry here, and I'm going to make 2 lines. Just like that. We're going to say T for tangent. We're going to make sure that this is tangent with this. E for equal to give these an equal length. And then we are fully constrained. So I'll go back to driving geometry. We're going to grab a B-spline, and let's do something interesting. I'll make the first 2 points, of course, on this line, on either point of this line, and it ensures that whatever I do with my B-spline, it's always going to be tangent. We'll go way below our sketch, way above our sketch again, and generate this sort of asymmetric, interesting curvature. And we'll close that. That should be interesting as the spoke develops down that path. I'm ready to make my spoke. We'll go to curves. And from curves, I'll show my sketch 007. And before I actually generate this, I want to use this pipe shell feature. And I need to have pipe shell profiles to do so. So I've got my sketches, and I can select, say, sketch 7 to begin with from the tree. So the whole thing is selected. And then I choose a pipe shell profile, and what happens is it doesn't just turn blue. It creates this fit spline, as you might know it, a spline that replaces the whole profile of everything so that there's no points. Everything's a lot more smooth. Again, with sketch 10, we'll click this button, pipe shell profile, and it again becomes what you would think of as a fit spline. Now we'll do a pipe shell profile, and here's a little thing to keep in mind. I hit my 2 profiles from the tree, I go select my mixed curve, and everything looks good. I click on pipe shell, and nothing happens, right? So there's a little thing that you have to know. I select my 2 profiles from the tree, but then I select from the graphics display window, and the pipe shell works great. You'll notice that the path is outside of our first sketch and inside of our second sketch. Really doesn't matter because it's made an interesting and compelling and really perfect transition. So this is what our spoke looks like right now. I can stand on my pipe shell and change some of these properties. So the output, let's make that, instead of sections, we'll make it a surface. And it converts that to a surface. Much more useful. We can be more useful still. So I'll go onto my pipe shell, and we're going to select solid is true. And just like that, we have a very solid. I love this spoke. You can see that it is going into where our lug nuts are. So let's tune that so that we can have some nice geometry and not have to worry about it. So again, by the way, this pipe shell was made in the surface workbench. So if I collapse my part design body, we can see that the surface exists outside of my part design body. And we're going to just do a Boolean as we've done before with references in the tree. But first, let's create something that will trim this spoke so we don't have to worry about it. I'm going to go with sketching on the XY plane. So again, we'll go to Sketcher, create a sketch, and we'll choose plane face. And from here, you know what, I actually need to close it because I need to go find my groove, which is right there, and show my sketch that created this originally. Now I can go to my sketch 11 and jump back in. I'll use this option to trim my sketch so I can see things. And there's my original sketch profile. It's perfect for what I need. We'll import some lines on this. There we go. We'll import that. We'll import that. And that. That should be enough. I'll select my multi-line here, and we can go from here to this point, from here to this point, to there, to there, and there. All I need to do now is add a horizontal there and a vertical there. And we've done it. So we have a fully defined sketch that sits right in there. We're going to go to our part workbench now. And we're going to do a revolve, right? There's our revolve. We'll choose an axis by selecting a reference there, and we'll say OK. Just like that, we've generated something that sits right inside of that hole. And again, these are not merged bodies, so we don't really have to worry about this coming to a point where there's a fillet on the inside right there or anything like that. We'll head over to draft because we need to pattern this for a proper trim. So I'm going to choose polar array. We're going to choose reset point. I'm going to make sure here that my revolve is highlighted. And then I'm going to say OK. So I have 5 elements. We're saying OK. Just like that, we create a polar array of this kind of pattern. I'm going to take my bar and drag it down here so I can see all my tools and just click this little hash or pound symbol to hide the grid. Now with this array, we'll go to the axis and we can see that we're revolving around or patterning around the wrong axis. So we're going to give Z 0, we're going to give Y 1, and just like that, they'll snap to the right spot. Now I want to use these to trim my spoke. So we'll head back to part, and we're going to select first the body that we want to trim, and then we're going to hold Control and select the tool that we want to trim with and cut. And one thing to be cognizant of, right? We have this inner surface and this surface. They're both sharing the exact same, they're like co-surfaces right now. That's on both sides of the spoke. So if we have a problem, one of the big things, especially with Open Cascade, is look for these kinds of possible zero thicknesses. If there's a problem, we'll increase the size of that revolve that we've done and subtract more of our spoke, and that should take care of any Boolean errors. For now, we will call that good. I'm going to do another polar array because now I have my trimmed spoke, so we'll head back to draft, right? We're in kind of array mode right now. And we'll choose polar array. We're at all zeros, 5, good, we say OK. Oh, and I guess I have to highlight my cut. We'll head back to tasks and we'll say OK. There we go. Again, Z is 0, Y is 1. And now we are correctly placed. So we've successfully created this whole body. And now, with this success, we're going to create a group. We'll call it spoke formation, right? And then I can choose all the things that contributed to my spoke formation. So that polar pattern did not, but sketch 7 did, 8, 9, going to mix curve, these sketches, right? Everything gets dropped into spoke formation because they're not part of that part design body ultimately. Some of the sketches were made from part design, but everything was made outside of part design as a solid. So if we want to edit our spokes, we can go into this folder and have our full edit capability. Otherwise, right now, I'll just stand on my array. We'll go to part design. Again, with my part design body being active, I'll double click on the body. And standing on the array, we insert a shape binder. From there, I can hide my array again with the space bar. And I'll hide the sketch as well. I've got my shape binder that is linked to the spoke. So if I change anything with that array and the spoke and everything, it updates in the shape binder. So it's fully updating, just as you would expect. And let's stand on this binder. We'll go to part design and do a Boolean. And again, if we come across some errors, we're going to change the dimension of that revolve. But we have no errors. It looks like it went pretty smooth. So we're going to say OK to that. So we have this great set of geometry. We have some artifacts over here from the Boolean. That's OK. What I'll do is grab my YZ plane. And let's let's see here. This spoke is a good example of it going right through the YZ plane. So recenter my view, and we'll create a wheel profile based on this. So we're going to grab our polyline here, and I'm going to make up a wheel profile. Okay, let's say that that is my wheel profile, my rim profile, you might say. We're going to make sure that these are equal, and I'm just going to be fully constraining a sketch. It's time consuming, it's boring to watch. If you're at this level, you definitely are good at not needing. So I'm just going to hurry and constrain this, and I'll see you on the other side. Alright, so this is the fully defined wheel offset profile. Again, just define yours however you want. I don't know if there's an exact science to it or what. We'll go with making all of this for construction. And then I'm also going to trim my view here. We'll add some sketch fillets. All right, we'll keep these pretty modest. And we're going to say this will be 0.075. We're going to hit E for equal and get all of these at the same radius. Wow, I'm having a hard time clicking. So get these all at the same radius here. Okay, so we've done that. Everything's the same radius. We have 4 degrees of freedom. It looks like we eliminated some constraints here. And there we go. So we're fully defined again. And then highlight everything. We'll go to our offset here, right? And we can make an offset where I can type in 0.0625, and we can see that we still have a little radius there if that's important to us. So that's one benefit of making all those radii equal. Now, of course, the offset is not fully constrained, and so you can either fully constrain it, fair amount of work, or you can say if I make any changes, I'll just delete what's white and then keep or re-offset my center when I'm done. For the sake of time, I'm not going to make you watch me sit there and constrain any more than I have to, so we're going to call that good. Just like that, we've completed our sketch. I'm going to do a revolve now, and this will be an additive revolve, and I'll specify my y-axis. And that is starting to look like a wheel. Okay. Excellent. This shallow angle here might be pretty favorable for some fillets or chamfers later on. If Open Cascade allows us to. Again, I'm not trying to criticize Open Cascade. Brilliant work. I'm very encouraged that they're still under development. So we'll grab this plane here. And now I want to import some things from my wheel. In fact, maybe I'll close this real quick and show my revolution sketch. And that's on a different plane, so I'll get rid of my sketch 13. We'll sketch on this plane. And trim here, trim our view so that we can see our sketch. Now I care about everything that is currently overlapping with that spoke sticking right out of our wheel. That should be it. So I'll grab a 3-point arc. Right there. We're going to say E for equal, just like that. I'm going to grab a line here, grab a multi-line there, to there, to there, to there, to there. I'll say V for vertical here, and we'll give this a bigger dimension just to make sure we capture all of it. I think that's good for the wheel, right? We'll go horizontal. And I believe we're safe to go vertical. Oh, wow. That is close. Maybe I'm going to Control Z that and just keep it at an angle. Where are we not fully constrained here? I guess we should have been constrained there. It's probably me. There we go. We'll close and we'll do a revolve, right? A revolve cut, or groove as we say in part design. We're going to make sure that we go around our y-axis, and just like that. Look at that, we're doing good. So we're going to say OK to that. I can go ahead and hide some of these profiles with the spacebar. Excellent. I can hide my sketch as well. So we are starting to look good. We have some, again, facial artifacts. It's not a big deal. Okay, so that is our wheel so far. Looking pretty good. All right, now that we have somewhat of a wheel going, let's start adding some aesthetic features to our spokes, as many beautiful wheels do. I'm going to start a sketch on the XY plane. I'm going to start, actually, let's not go with an arc rather, but a circular slot. And I can start to dimension these, right? I'll make this arc center horizontally 1.65. This one vertically, we'll go 2.5. And then we'll go, this center will be 4.9. This center, let's say 5.35. We'll make this a size of 0.3. And maybe I'll give this outer radius, just something to define it, 9.5 I think looks about right. So we're going to close that and pocket, let's say through all. So we'll OK that. And I can do a polar pattern with my pocket. And we're going to say transform tool shape. We're going to add, of course, our pocket and make it go around the y-axis. And we're going to give it 5 features instead of 2. And we have a beautiful transform. It's starting to look kind of trendy. I really like that cut. Now we're going to say chamfer. And I'll make that chamfer size a 0.2. And we'll select some of these outer edges. Of course, the tangency will propagate the chamfer all the way around. And once selected, I'll say preview, and that looks right to me, so OK to that. So I think the chamfer and the groove really give the wheel a bit more character. Let's continue that trend and make a nice cutout. We might call that a project, a wrap, something like that on the spoke to give it some more surface variation and nice aesthetic look. So I'm going to start, we're going to have to do this again off of part design. We're going to go to curves. And from curves, we're going to do something like in a Libre, you would call it create surface from face, right? I highlight the surface and I choose extract subshape, and that creates a surface. Now we haven't lost our wheel, it just automatically has made things invisible, which is actually really convenient if you ask me. And then I'm going to choose my plane again, right? This is my XZ plane, and go to the sketcher, create a sketch on our plane face. So I'm going to create a little freehand shape that just gives it some more interesting surface variation. Again, choosing a B-spline. I'll come around here. I think how might I want to wrap a surface around this face that would look pretty interesting. And just like that, I think we've done it. I'm going to move this guy a little bit further out. Yeah, I think that looks not too bad. Smooth, non-constant radii, very interesting. So we're going to close that. And we're going to go to the part and extrude. We want to extrude a surface, not a solid. So I'll choose my sketch and we're going to choose extrude. There it is. We're going to uncheck create solid. I'm going to say symmetric so I don't have to worry about the orientation or the direction. I'm going to say 10 inches, 5 in both directions. And oh, I guess I should have made it a bit longer. We'll oh, and I made a duplicate extrude there, so we'll get rid of that. And we're going to say 15. Now it goes through both ends. So I'm going to choose first off my face that I want to keep, and then I'm using this extrude as a trimming tool, and we're going to say slice apart. And just like that, I can choose the surface that I no longer need and either hide it or just hit the delete key and delete it. That slice apart tool has been one of my favorites for a long time. Now we can select this surface and create an offset, and that's already not looking good to me because I don't see an offset happening. So if I try to say okay, nothing happens. If I try to fill it, nothing happens, and we're just offsetting it a millimeter. So there's not much hope that that's going to work. But I think what I can do is select this surface. We'll go to curves and we'll select subshape. That essentially duplicates the surface, right? And in that we should have, yep, we've made our exploded slice invisible, so I'll show it. You can see the graphical mesh there between the two identical surfaces. And so I'm going to take this face, I'm going to right click, and I'm going to choose transform. We're just going to move this surface. I'm kind of losing my bearings here. I'm just going to show my wheel real quick. Okay, that's how we're looking. So yeah, we do want to move it down our y-axis, right? So we're going to say our child face is going to be transformed, and I'm going to transform it 0.25. So 1/4 of an inch, maybe 0.27. You know what? I'm actually going to say 0.51. 0.51, and we're going to move that down 1 notch, and that's 0.51. And then I can go to my surface. There it is down here, surface. And I'm going to choose this guy, the sections. And I'm going to click add edge and create this outer section and this outer section. And that kind of walls it off. So we have this watertight set of surfaces, which is exactly what we need. If I highlight each of my surfaces, I can click on create parametric solid. And now I just converted that into a solid. Isn't that like really neat? Okay. So I can take my solid, and if I show my wheel, right, I've got one body sitting right inside of my wheel, and I made that 0.51 for a reason. The reason is I want to transform again. Notice that there's all this zero thickness area, and it's probably fine, but we can make it a lot easier on ourselves and transform it. So I'm going to say 0.01 as an increment. All right, so setting the transform here, I'm just going to bring it a little bit above the surface. And of course, our graphical mesh is probably a lot looser than 10 thou, and that's why we're still seeing some overlap. But you know, if we didn't approximate graphics the way that CAD systems do, this should be good. I'm going to say OK to that. Now I want to head over to the draft workbench and draft this. Now you'll notice there's nothing in the tree that says we transform this. So transforming is not parametric. Do it carefully so you don't get into trouble. right? You might transform something, pattern it, and realize that the original thing was up and the other things are in a different position. So just try to be careful when we do transforms. We're going to go to draft, polar pattern, 0, 0, 0, 0, right? And so we'll say OK to that. For array, we're going to change 0 for Z, 1 for Y. And that should get everything the way that we want. So I'm going to stand on my array, go to part design. We're going to go to the tree to make sure that we're still active. Yep, that body is bold, which is what we want to see. If not, double click it, of course. Then we're going to choose Boolean. And instead of fuse, we're going to change this to cut. We have some beautiful deep cuts that I'll accept. Finally, I'm going to create a group. We're going to hit F2 and name this maybe spoke indention. And I'm going to select all the things that are part of making that, right? Now I'll hit F2 here, and we're going to say there we go. And then we have our array down here, which I think is a shape binder, and our spoke indention. So let's say that we wanted to change how deep this is. Let's say that's way too deep for our taste, we've decided. Well, what we would do is come in here and start exploring how this was put together. So there's my slice, and then there's that child of that slice. So I'm going to hide my other body and just go to this surface. And then there's my other surface, right? So I can right click, and just as if I were doing it before, I'd say 0.25. And we can just move this upward a distance of 0.25. There we go. So we'll say OK to that, and we'll see how this rebuilds. This will take just a minute because I think we're actually recomputing the Boolean that we did in the background, and that was a pretty computationally heavy thing for FreeCAD to do. So we'll take just a moment to do that. Okay. So now if I maybe hide this and this, and I can show my surface, yeah. My array also needs to head in here. So there's my array. That looks narrower to me. So let's see how that turned out. Yeah, we're much thinner. So hopefully you're able to see the difference. We can still go into our folders, edit our stuff, the shape binders, update the appearance of our wheel. So hopefully that's a reasonable example of how you might do things. I'm going to go ahead and save. And that is our wheel so far. So now these wheels have some, weight reduction features in the back of the spokes quite often. So let's see if I can turn the wheel around. We should add maybe some weight reduction back here. And I think that's mostly what I want to do with this wheel. There could be some fillets and chamfers if the kernel will let us. If not, that's the way it goes. So let's jump on this XZ plane here. And I'm going to create a B-spline that is once again intended to just be a weight reduction feature. Something that's, kind of smooth. Not bad. So I'm going to follow the same procedure as before, right? We're going to go to Part. We'll choose Extrude right there. We'll make this distance of, say, 15 inches. And we're going to go uncheck Create Solid, make sure it's symmetric, Apply. We're going to take this face, and we'll head over to the Curves workbench. Oh, and I have to close that, of course. And then we'll go to Extract Subshape from that face, just like that. Now once again, in the Part workbench, using a wide variety of tools here. Select my face and this other part. It's probably best to select that from the tree, right? So we'll select our Boolean and our Extrude, slice apart in that order, and delete the face that I don't want. Once again, we can try to offset. I don't have that much confidence, not looking good. So we'll do our fallback here and head back to Curves. Select this face and create a face from the sub shape. Now I can show both faces and see that mesh that we get. We'll translate this downwards, or no, upwards, because we're at the back of the spoke now. So we're going to transform. I'm going to say 0.5 because they tend to be kind of bigger at the other end of the wheel. And we want to use our y-axis, so we're going to just go one click up. There it is. Okay, again, we'll go to the surface. We'll go to our profiles. Just as we've done before, we're going to add edge there and there. And with our watertight surface, we can head back to Curves, highlight all three of these things, and create a parametric solid. From there, I think, just to be safe, I'm going to transform it down. I'm going to say 0.001 as an increment, and just that far, right? Just barely, so that we don't have any of that zero thickness stuff, just as a precaution. And then we'll select our solid. We'll go to Draft, Polar Pattern. Right, we got 5, everything at 0, so we say OK to that, and change from 0 to 1. And we have that. So I'm going to grab the array, we'll go to Part Design, and grab our shape binder. Right, we've done all this before, it's just familiar now. And then we'll hide the array. I'll bring our Boolean into view. There's our shape binder, right? Just barely move down. And I'll stand on our binder and make a Boolean cut. So there we have a fuse. Let's go to cut. And there is our cut. We're going to say OK to accept that. Okay, with that being done, you can add a fillet, right? We've got a kind of a sharper edge right there. And I think we're going to be allowed to fillet this. We are. Maybe we'll make that 0.125 and see where that takes us. It's not bad. I might have to go bigger. Let's try 0.5. That doesn't look different from the 0.125, so something's telling me that's not working, and it's not. We're going to say 0.25 and see how that goes. Yeah, looks like 0.25, 0.35. I'll go there. All right, so we go to Select. So I'll say OK to that. From here, maybe I want to make a fillet. Again, that's defaulting at about 1 millimeter. Let's see what that looks like. Yeah, it's letting us fillet that. Pretty clean. Wonder if I can select this top face as well. Beautiful. Doesn't like 0.125. But it likes 0.075. So we'll go to select and just round out these bottom faces. So we have some nice smooth transitions behind these spokes. Love it. Maybe another fillet right there. Maybe a chamfer works better there. I don't know. Either way, let's see if we can do 0.25. We sure can. Okay. Well, that is going to be a wheel. There could be some other videos I'm going to make off of this model, but this is the best wheel that I think I've ever made, and I'm glad that I had you, the viewer, to celebrate it with. Now, maybe before I end, right, I do like experimenting, even if it's on camera. I want to revisit filleting this edge right here. I've tried it. I might have tried it off camera. Let's try 0.125 and preview that. Yep, so that worked. Now if we do this one, that works. So if I select the rest of them, right, I mean this is all pattern stuff, so it should be identical, but yep, we get some that aren't showing up. And so when I go to apply this, I get an error. So I'm like, you know, what if there was a way to root out some problems? If I know that this edge is good and this one isn't, then what if I create a sketch on this plane? Well, you know what I'm going to do? I'm going to fillet this first so I can recall. Fillet. Okay, so I've got my fillet on there. And I create a sketch on this shape here. And I know my fillet is connected with that spoke right there. So if I assume that this spoke is good and that there's some geometry somewhere else that's throwing off the integrity of our sketch, what if I put a line right there in our origin, and I make another line, and I create, again, D for distance, or dimension. I make a line that's 72 degrees, and maybe I'll import this circle here, and I'll say C and get that right there. Fantastic. Give this a dimension 14, let's say. E for equal. Spread that dimension there. And then I put an arc right there, and I cut everything out. Is this making sense where I'm coming from? Say C for coincident. This is just kind of a last effort. There we go. So that's not centered. I can just hurry and center that, I suppose. That's going to cut out exactly what I want and nothing more. So did that equal not apply to that line, I guess? Okay. Yeah, we're fine. I'll just give that a dimension so it's fully constrained, but we're obviously cutting out what I want. So if I cut out that section of the wheel and I say pad. Now if I go this route, this is very inefficient, of course. The argument is, why didn't I just model a fifth of the wheel to begin with and then pattern it? Why do all the computation of everything just to delete it at the end? But if one fillet works on one edge and it's supposed to be identical and doesn't work at the last, then this could be worth a try. So say through all, I'll say symmetric, so it's just through everything, and okay. Now we'll just see if I can pattern this, right? So I'll go with polar pattern, and it defaults to the body, so we should be good there. We're going to say 5 instances over our y-axis. Anything can happen here. I mean, this is a huge pattern. Oh, and we're calculating the 5 instances, of course. So then I'll choose the y-axis when it's done thinking about it. Okay, well that took long enough, but I can now change it to our y-axis and see if this will succeed. Sometimes, and this is not just FreeCAD, in many platforms, when you do that involved of a body pattern, sometimes some extra cuts and other features that you didn't intend can mess something up. So I'm lukewarm. We'll see if this works or not. And wow, looks like it worked, but we get a little bit of shenanigans right there, right? In fact, all of these have shenanigans there. So it might be worth looking into. But looks like that could be an option, right? So in the future, if you have a hard time with one part of a body, doing a body pattern, if there's symmetric pieces like this, might be a cool strategy. If we didn't have just that one thing, it looks like everything else would be perfect. So I'm going to give it up there. I'll probably delete my pocket. I can get rid of that sketch. What is the sketch 17? I think I've got a blank sketch, so I'll just get rid of that too. So hopefully this video was helpful. What a journey it was. If this is helpful, please subscribe, and I'll see you in the next one.